Hi girls, here's a video to help you with your formative assessment task 1. I've got a video to take you through the steps, but if you just want to check some of your answers, there's also the answer schedule uploaded on Alternet. The question here says, April collected the following results from her titration of sodium hydroxide against hydrochloric acid using phenolphthalein indicator. You're given the chemical that was put into the burette and the chemical that was in the pipette. The burette had 0.100 mole per liter of sodium hydroxide. Now, mole per liter tells you that the physical quantity there is concentration. It's the unit for concentration. So you can circle that and say, I know the concentration of sodium hydroxide. Then they've said that the pipette had 20 milliliters of hydrochloric acid. So milliliters or liters, immediately you know that that's volume. And this time it's for the other chemical, hydrochloric acid. But what you don't know is, you don't know its concentration. So really the whole experiment is trying to find the concentration of hydrochloric acid. Now before I start, what I will always recommend you do is, you have your little calculation triangle, all right? So you have N, which represents the number of moles, a lowercase n, a lowercase c, which represents concentration, and an uppercase V, which is volume. All right. So your N is going to be in moles. Concentration is in mole per liter. And your volume is always in liters. All right. So anytime you're going through the steps and you need to, you're calculating concentration, make sure that that is your unit. You found out moles, that should be a unit. Volume, that's always the unit you must convert it into. What I also do is, before I start, I recommend you do this, is make two columns, known and unknown. Known as in whichever chemical you're given the concentration of. So sodium hydroxide concentration given to us in the problem, 0.100. The volume of sodium hydroxide. So I'm trying to find the N, C, and V for each of the chemicals here. So the volume will come from the table that's here. So we'll do that in a few minutes. And if I know C and I know V, I can calculate N, because N will be C times V. Once I find out the number of moles, N is the number of moles of sodium hydroxide, I can use the balanced equation to find the number of moles of hydrochloric acid. All right. And when you found the number of moles of hydrochloric acid and I know its volume, I can find C, because in that case C will be N over V. So that's really the outline of how we're going to get to the concentration of hydrochloric acid. It's a 3-step process and I'll take you through that. But before we do that and before I look at this equation, you will be given a balanced equation always, so you don't have to worry about balancing it. And really what they want you to do is determine the mole ratio. So we'll just quickly look at this. It says 1 mole. There's no number here in front. That means it's 1. And it's 1 mole of hydrochloric acid reacting with 1 mole of sodium hydroxide to give 1 mole of sodium chloride and 1 mole of water. So we'll leave that aside for now. I'm going to use that when I come to step 2. Now in the meantime, I have here a table of results. This is for the chemical sodium hydroxide. This is a table that you will be drawing. You won't be given a table in the practical exam. So you need to draw this up. So pay attention and see how this is done. You have final volume and you have initial volume. And the final volume is always on top, so that you can subtract these two. The difference can be found easily. The difference is put down here as the volume that was actually used. And then from these volumes, you're going to pick concordant results. What is a concordant result? They are results that are within 0.2 milliliters of each other. So once I found concordant volumes, I will put a tick next to those, and I put a cross next to the ones that I don't want to use. One of the results that I will not be using is the rough. Okay, so here I have, these are from the burette when they did the titration. So the rough is just to give you an idea of your endpoint, so I'm not going to choose that. That leaves me with 4 other tighter volumes, 24.15, 24.45, 24.30 and 24.20. The difference between these two is 0.3, so I definitely won't take those two. Difference here is 0.15. The difference here is 0.10. So of these three, I actually choose the first titration's volume. I'm not going to take this. I'm going to take the third titration's volume, and I'll take the fourth one. So if you look at the difference between these two, it's 0.15. The difference between these two is 0.05, and the difference between these two is 0.1. Alright, so it's within the range for them to be concordant. So what am I going to do using these three volumes? What I need to do now is find the average volume of sodium hydroxide. So I write down the volume of sodium hydroxide is equal to these numbers here, 24.15 plus 24.30 plus the last one, which was 24.20. And since I'm finding average, I add them and divide by 3. So if we take our calculator and enter these three numbers and divide by 3. Okay, so the first number there is 24.15 plus 24.30 plus 24.20. Alright, divided by 3, and I'm going to write down all the numbers that are there on the calculator. I'm not going to leave any of them out. So the answer here will be 24.21666667, and when you're calculating volume, your unit is liters. Milliliters, because that's the volume that was given in the table. So it's milliliters, so your average will also be in milliliters. But you do know that in all your calculations, your volume must be in liters. So to convert from milliliters to liters, I divide it by 1,000. And so my volume is, how many liters will that be? 0.02421666667 liters. I underline that so that when I actually come to the calculations, I don't forget to use it. Alright, so the last thing, the 3 steps that we need to go through now is we've got the volume. So I've got the concentration. I was given the concentration. I've got a value for the volume. I can now calculate the number of moles of sodium hydroxide. So step 1 is number of moles of sodium hydroxide. Alright, and I'm going to calculate that by, how do I calculate number of moles? It is C times V. Alright, so I write that down. It is concentration times volume. So notice that's lowercase and this is uppercase. So what are these two numbers? Concentration was given to us in the question. It's 0.100 mole per liter times the volume, which is 0.02421666667 liters. So I've just got the volume as I calculated there. You notice that don't clear your calculator at any time. Leave the numbers exactly as they are. That means you can avoid having to key them in all the time. So I've got this number sitting on my calculator already. In fact, not. I need to divide this by 1000 because we converted that to liters. Now I do have that number. All I need to do is multiply it by 0.100, which was the concentration of sodium hydroxide. So my answer on the calculator says it is, sorry about the glare there, 2.421666667 e to the power of minus 0.3. So what is that e? It is just exponent, that is 10 raised to the power. Alright, so I'm going to write this number down in my answer sheet. It's 2.421666667, and e is exponent, that means into 10 raised to the power of negative 3. Alright, what have we been trying to calculate here? It is the number of moles. So what will the unit be here? MOL. So always make sure that you've got your physical quantity. What is it that you're calculating? It's the number of moles, and you've got the unit MOL. So that's step 1, that's done. Now I'm going to go to step 2, which is we need to look at the balanced equation that you're provided in the question. Okay, so the balanced equation says 1 mole of sodium of hydrochloric acid reacts with 1 mole of sodium hydroxide to give us 1 mole of NaCl and 1 mole of water. These two chemicals, I really don't need them. So I focus on the mole ratio here, 1:1. So the ratio here is 1:1. If you have 1 mole of this, you have 1 mole of this chemical. So what does that mean? So I'll say from the balanced equation, HCl is to sodium hydroxide in 1:1 ratio. Alright, so what if you don't have a 1 mole? You have much less than 1 mole because it's 10 to the power of -3. So that means if this is the number of moles of sodium hydroxide, it's also going to be the number of moles of HCl. So now I know that N of hydrochloric acid, because they're exactly the same. If I had 1 mole of sodium hydroxide, I'd have 1 mole of hydrochloric acid. If I had 2 moles of sodium hydroxide, I'd have 2 moles of hydrochloric acid. If I have 2.421666667 into 10 raised to the power of -3 moles of sodium hydroxide, that is exactly how many moles of hydrochloric acid I will have. So it's 2.421666667 into 10 raised to the power of -3 moles. So I've got the number of moles of hydrochloric acid now. I go back to the little table that I made here. I know the volume, I know N. Can I calculate C? Yep, we can do that. That will be our third and final step. So I write down here step 3. And here I'm going to calculate the concentration of hydrochloric acid. How do you calculate the concentration of hydrochloric acid? C is equal to N over V. Alright? So that's equal to the number of moles of hydrochloric acid over the volume of hydrochloric acid. Okay? The number of moles of hydrochloric acid is the same number that I have here, which is 2.421666667 mole. Into, very important, into 10 raised to the power of -3 mole, and this is divided by the volume. Where do we get the volume from? They were given it to us. It was 20 milliliters. We converted that to liters, so that's going to be 0.020 liters. Alright, so bring a calculator. I've got the numbers. This number, the numerator is sitting already on the calculator, and that's why you don't want to ever clear your calculator. All I have to do is divide this by 0.020, and my answer, which I'm just going to copy all of the numbers from the calculator, it is equal to 0.121083333. So there's 1, 2, 3, 4, 5 threes. So I just make sure that I've copied that all correctly, and the answer here is mole there and liter in the denominator, so it's going to be mole per liter. But that's not our final answer, because the answer says that it should be to 3 significant figures. How can I take this answer and make it 3 significant figures? So I start working from the left, and then I move to the right. Alright, this 0 to the left of decimal is not significant, so I can't count that. 1 is a significant number, so I underline it. The next number is 2. It's a significant number. I underline it. Then I have 1. That's a significant number, so I underline it. I've already got 3 significant figures. I don't need any more. But before I round it up, I want to look at the the digit in the fourth place here, which is 0. It's less than 5, so I don't need to round this up. If it was greater than 5, I would round this up and make this as 2. So for now, we can leave it as it is. So my final answer will be 0.121 mole per liter. Alright, and I might just say here what it is it's the concentration of hydrochloric acid, or you can put another sentence saying that's the concentration of hydrochloric acid. Alright, so I hope this was useful for you, and have a look at this, and I hope you can complete formative assessment task 2 as well.